So remember in this, one of the big things we did in this lesson was learn a new angle measure called radians. And we learned that to convert from degrees to radians, what did we do?
No, pi for actually form the
Multiply by what?
pi.
And what if I want to go the other way, radians to degrees? Times 180 over pi, good. And then we also talked about coterminal angles, which we're going to revisit a little bit later on in this unit. But I do, this last piece of this lesson is just talking about a formula and applications where we can use radians. Okay, this is a formula where in order to use it, the angle that you're using in the formula has to be in radians. Okay, if you remember at the very beginning when we talked about radians, okay, we said that 1 radian occurs when the radius of a circle is 1 and the arc length between these two radii is 1. Okay? If all of these are 1, the measure of this angle is 1 radian. And we actually give this angle, an angle that comes out from the center, like so or like so. We actually give a certain name. We call it the central angle. Okay? So if we look at this situation, we can conclude that the ratio of the arc length of a circle or portion of a circumference to the radius will always be equal to the measure of the central angle in radians. So if we call this arc length S, and if we call the radius R, which we normally do, okay, S over R will always equal the measure of this angle in radians, okay? So if I said this was 10 units, centimeters or whatever, this was 5 centimeters or units or whatever, what would the measure of this angle be in radians? 2. Because it's just S over R is equal to 2. That's the relationship between. Okay? And then I gave you an example here. If you have a central angle that opens with a radius of 3, that opens up to an arc length of 6. So if this is 3, and this is 3, and this is 6, this is going to be 2. Okay? Because the measure of the central angle will always be the arc length at the end of that angle divided by whatever the length of the radius of the circle is. And if we took this formula, which I just wrote over here, and if we multiply both sides by R, well, the R's would cancel. And therefore, the slant length would equal the central angle times whatever the radius is. Sorry, slant length. The arc length. So S stands, make sure you know these. S stands for arc length. R is the radius. And theta is whatever the measure of the central angle is in radians. You cannot use this formula unless the angle is in radians. So if you're given something in degrees, you're going to have to convert it to radians. So for example, we've got a wheel that has a radius of 0.5 meters and it rolls. That means that's the arc length because it rolls a total distance of 1.5 meters. How many radians has it turned? Well, we use this formula. Do I know what S is, the arc length? How much it's turned? What is it? 1.5. Do I know the radius of the circle or object or whatever circular object it is? 0.5. It's theta. I don't know. So plug in what you know and solve for the unknown. So 1.5 is equal to theta times 0.5. Well, how do I solve for theta? Divide both sides by 0.5. And I get theta is equal to 3 radians. And 3 radians is approximately how many degrees? No. We don't normally use the pi symbol when we talk about degree measure. Only when we talk about radian. You might have just got yourself mixed up there a second. 3 radians. We talked about this. No. It's not in your notes. You have to understand. What's that? 180-ish. Why? Because didn't we say there were 6.28 in a complete circle? 2 pi radians in a complete circle. 2 times 3.14 is 6.28. So 3 radians, around 180. Oh, look at this. Are you passing notes or mints? What are you passing? Well, I will one. Thank you. Okay. All right, here's another example. Sophie is taking a course in industrial engineering. For an assignment, she is designing the interface of a DVD player. Do those things even exist anymore? Yeah, they do. In her plan, she wants to include a nice decorative art below the power button. But she wants to know how long to make it. She's measured the central angle from the power button to be 130 degrees and the radius to be just 6.7 millimeters. How long does this have to be? You're smiling because you like this question so much, right? Absolutely. What do we know? Do we know S?
S is 130 degrees.
S is 130?
Oops.
F is unknown.
Sorry.
This is what we're trying to find. Yes. But it has to go to radians.
R is 6.7 millimeters.
And R is 6.7 millimeters. That's correct. But remember, I can't use this formula until it's in radians. How do I convert 183 degrees to radians? Times pi over 180. So we can do it all in one shot because you're asked to round this to the nearest 10. So S is going to be 130 times pi over 180. That gets us radians, right? And then what are we going to multiply this by?
130.
I'm already multiplying by 130. What do I have to multiply this answer by? This gives me the angle in radians. This is theta in radians.
What's that then?
I have to multiply by 6.7. And then we get S is equal to approximately, wow, 130 times
15.2.
15.2, she's saying.
15.2.
That is, nearest tenth is 1, so 15.2. Okay. Remember, has to be in radians to use the formula. Final question where we can use this formula. We're given this diagram, we're asked to find the measure of the central angle in degrees. Where's the central angle? Which one? This way or this way? This way. Because I'm not given this. I'm given this arc length, which means I'm dealing with this bigger angle. So this is theta. So we can see here that we're going to use our formula. We know that S is 25. Theta is the unknown. And R is 5. So plug in what you know. Theta times 5. What's theta going to be? 5. Don't forget, that's radians. Right? But I'm asked to find it in degrees. What do I have to do with this to make it degrees? Times 180 over pi. And then 1 decimal place. 180 times 5 divided by the pi key. 286.5. And remember, this is degrees, so you need the degrees symbol. Okay. So now you can finish all of exercise 4.2. Okay.